Hello everyone, my beloved students. I hope you all are fine. You all are doing well. You are staying back home. You are safe, and at the time you are also keeping up your studies because you cannot be deviated. Anything happens, you have to carry on with your studies. So let me tell you one thing because I don't want to make the video very long. First of all, my strategy will be I will make short videos. That means a video will be of 3 to 4 minutes duration. Topics will be taken, topics will be covered, and number of videos we are going to increase. That is, we are going to make some more number of videos, and covering in every video we are giving a particular topic. I don't want to make a video of 1 hour length because right now I don't want to put some effort for editing the video, for wearing good clothes, for articulation of the video. Just it will be a raw video because this is the critical stage going on, and we would like to फोकस ऑन द मटेरियल एंड दिखावे पे नहीं हम लोग ज़्यादा जोर देना चाहते हैं यहाँ पर. माई मोड ऑफ टीचिंग विल बी इंग्लिश एंड हिंदी. Definitely, as I have some of the Bengali audiences, so obviously sometimes little bit Bengali, but most of the time I will be teaching in you with English and Hindi language as I do in the offline classes. Well, so without wasting time, let me go with this one. So you can understand we have given the we have given the heading as part 2, elevation in boiling point. So elevation in boiling point is this, the topic name. So some of you have already covered the first part, that is solution. What is solution? What are colligative properties? What is the vapor pressure? What is the relative lowering of vapor pressure? Raoult's law. This all were in the part 1. And I have made a video on that also. Will also be uploading for those people who have missed that class. And right now we are going for the elevation in boiling point. So first of all, my dear, I have already told you that boiling point is basically that temperature at which the vapor pressure of a particular liquid becomes equal to the atmospheric pressure. That means we have in a container some amount of liquid particles here. Atmospheric pressure is from here. This molecule is having a collision with this molecule. This molecule is having a collision with this molecule. The kinetic energy of this molecule is getting increased, and the molecule is trying to come out of the surface. So who is obstructing that molecule to come out of the surface is basically the atmospheric pressure. So whenever this vapor pressure, that is upward force, vapor pressure is nothing but the upward force here, is becoming equal to the atmospheric pressure, then at that time we call that this temperature is nothing but the boiling point. Clear? We have already understood one thing, that at the boiling point atmospheric pressure becomes equal to the vapor pressure. Rather we should say vapor pressure becomes equal to the atmospheric pressure, because for that particular temperature in that particular area, in that particular altitude, you have the fixed value of the atmospheric pressure, but you are trying to increase the vapor pressure to that level so that this vapor pressure can be equal to the atmospheric pressure. Now we have taken a graph here. I would not say that is a very much scaled graph. It is just a plotting of the whole scenario. So what we have in the y-axis, it is the vapor pressure. In the x-axis it have temperature, and you see in pure solvent, so this is the vapor pressure increasing, and at this point, that is this temperature, this pure solvent's vapor pressure is becoming equal to the atmospheric pressure. So what can we call this corresponding temperature T0? It is the boiling point of the pure solvent indeed. For the solution, this is the point at which the vapor pressure of this solution becoming equal to the atmospheric pressure, and this temperature must be the T1. We understand that if I have taken the container and this is the pure liquid, so this pure liquid, when it is trying to convert into vapor, then what is basically happening, that the upper surface is full of liquid. There is nothing else. Only what is present there is nothing but only the pure solvent, that's the pure liquid. But once you add some salt particles here, So the upper surface is now not only occupied by the pure solvent but also the salt particles are present there. So naturally the number of solvent particles present here will be less, and definitely the produced vapor will also be less. Naturally the vapor pressure will be less. So the solution has lower vapor pressure than that of the pure solvent. You can just pause the video and again come to the starting point and again see the video one by again and again, and then you proceed, because that is the main idea, that you should understand the whole concept as you understand in the offline class. ओके, सो पॉज दिस वीडियो, और जो भी दिक्कत होता है किसी को कमेंट में बताइए. यू हैव सब्सक्राइब द चैनल, कमेंट में जाइए और कमेंट में बताइए और क्लियर बताइए क्या समझ में आ रहा है क्या नहीं आ रहा है. वी हैव ऑल द टूल्स, वी हैव ऑल द मॉडर्न टूल्स. देयर आर सम storage problem right now, so as I am making a very short videos and I am coming one by one. तो पहले ये वीडियो का फीडबैक आप लोग दीजिए कि ये अभी तक जो हम कह रहे हैं क्या साउंड क्लियर आ रहा है, क्या पिक्चर ठीक से समझ में आ रहा है, ये हमको थोड़ा जल्दी से बता दीजिए आप लोग. सो बेसिकली व्हाट इज हैपनिंग हियर कि इन द सॉल्यूशन वी हैव लोअर अमाउंट ऑफ वेपर ऑन द अपर सरफेस. सो ऑटोमेटिकली लोअर अमाउंट ऑफ सॉल्वेंट पार्टिकल्स ऑन द अपर सरफेस, तो वेपर भी कम बनेगा, तो वेपर प्रेशर भी कम होगा. वेपर प्रेशर कम होगा तो बॉइलिंग पॉइंट क्या होगा, ज्यादा होगा. तो इसी को हम लोग बोलते हैं एलिवेशन इन बॉइलिंग पॉइंट.